Hello guys, welcome to another video of Circuit Digest. In this video, I'll show you how you can convert your fidget spinner into a BLDC motor. So as you can see, I have mounted this fidget spinner over this nut and bolt arrangement, and I have a small 12 volt electromagnet over here followed by a Hall effect sensor. So what actually happens here is this Hall effect sensor will read the polarity of the magnet and it will control this electromagnet to repel these magnets that is present on this fidget spinner. So let me go ahead and show you the working of the project, and then we'll proceed to the circuitry, and I'll also unmount the fidget spinner from this arrangement and show you how the magnets are stuck underneath and everything. So as you can see, I've used an L293D motor driver module, a 7805 regulator, a Hall effect sensor, a freewheeling diode and all those stuff. So the complete circuit diagram can be found at the link given in the description of the video. You can also find the theory behind this working and everything. So this video will just demonstrate you how the project works. Now in order to start the fidget spinner, to keep it rotating, you just have to give an initial push so that it cuts the Hall effect sensor. So let me just give an initial push, and that's it. The spinner starts to rotate, and since it's rotating very fast, the camera is not able to show you the actual speed. So let me zoom in a bit so that you can see the bearings over there which are rotating very fast. So, and you can just leave it. So as long as you have powered it with this 12 volt supply, your fidget spinner will be rotating unless you go ahead and disturb it or something like that. So you can just give it an initial push and it will rotate forever. As you can see, this LED is blinking every time it detects a magnet. So this LED is actually connected with this Hall effect sensor. So every time it detects the magnet, the LED is blinking. So that's it. It will keep on rotating, but let me go ahead and give some force, restrict it and stop it. And it's stopped now. Now let me remove the Hall effect sensor from its, okay, let me stop it properly. Let me remove the Hall effect sensor from its position. Now the sensor is removed from its position, and when it does not detect a magnet, the LED will always stay high. So let me go ahead and place it over here. So as you can see, it is directly connected with that LED, and when there is no magnet detected, it will just stay high. Let me remove the magnet from this fidget spinner, and when it detects a magnet, it will go low. So every time it detects a magnet, this will go low and it will activate this electromagnet over here. So it will keep on repelling this magnets which were stuck underneath it. So this is just an arrangement to keep it intact. Let me remove the bolt. So I have just removed this thing over from this threaded thing. Now let me take it out. So as you can see, it has a bearing inside which makes it very easy to make it as a motor. And I have just stuck these neodymium magnets. I have combined 3 magnets into a stack like this, and as you can see, this electromagnet will be repelling these magnets by detecting its polarity by using the Hall effect sensor, and every time it repels it, the fidget spinner will keep spinning. Okay, now let me pass it for a second. So this is how the arrangement should actually be. You should use neodymium magnets at the bottom of this fidget spinner. Since it already has an iron material, it will easily get stuck to it, and then you just have to pop out this. It will have a bearing inside. You just have to pop the casing in from the both directions and use this bearing on some arrangement so that it stays as close as possible to this electromagnet without actually getting attracted to it. So I have just used a threaded rod like this to make this arrangement, which is actually quite easy, but you can use anything that is favorable for you. So that's it guys, this is how the project works. Thanks for watching.